Hello everyone. So far for derivative, we have looked at the definition of derivatives, power rule, product rule, quotient rule, chain rule, and today we are going to have a quick review and then we will solve a few exam problems from top universities like MIT and Stanford. And actually there is going to be two series, and in each of them I will solve 3 problems from this universities, actually MIT, Stanford and Berkeley. Let's start a quick review on what we have learned so far in derivatives, and basically let's look at the rules that we learned about the derivatives. The first one and this easiest one is the power rule, and actually when we have a variable to the power of n, or to the power of basically a number, what we have to do is to bring that power to the upfront of the variable and reduce the power by 1, as you can see here. So when we are looking at x to the power of n, basically n is coming to the upfront of the variable and it's going to be nx, and then we reduce n by 1, which is going to be nx to the power of n minus 1. If you want to learn more about this and you want to have a review on the power rule, you can watch our previous video on the power rule. The other rule that we have actually looked was the product rule, and the product rule says when we have two separate functions and these two separate functions are being multiplied, like fx times gx, what we have to do when we want to take the derivative is we have to keep one function as it is, like in here. So we keep gx as gx and we take the derivative of the other one, which is fx. So we take the derivative of fx, as you can see, and then the second part is going to be we keep fx as it is and then take the derivative of the second function, which is gx, as we can see in here. So for the product rule, what we have to do, basically we have multiplication of two functions like fx times gx, and the first step is to take the derivative of fx and then multiply it with gx as it is, plus fx times the derivative of the gx. So this is the basically the product rule. The other rule that we looked was the quotient rule, and for this one we have actually a fractional function which contains fx over gx, and for this case what we have to do is first on the denominator part we have to put the derivative of the top function, which is fx, which is going to be f prime of x, and we have to keep the bottom as it is and multiply it with the derivative of the top function, as you can see in here. And as you can see in here, and the second term is going to be the derivative of the bottom, as you can see, the bottom, and then we keep the top function as it is. So it's going to be g prime of x times fx. So, and for the bottom function we'll keep it as it is but in power of 2. So you can see here gx to the power of 2, or the bottom function in the power of 2. The last rule that we actually looked and we have learned was the chain rule, which is one of the most important rule in derivatives. And the rule says that when we have a function like f gx, what we have to do, first we have to take the derivative of the outside function and keep the inside as it is. So if we look in here, the outside function is f and the inside function is g. So what we have to do, take the derivative of the outside function and keep the inside as it is, and then multiply it with the derivative of inside function. In order to actually have a review on all of these rules, you can watch our previous videos. and you can see lots of examples in there. Now we have actually a good review and actually a quick review on what we have learned based on different rules in derivatives. We can look at some examples from top universities, and you'll see that these examples are not that much complicated, and with your current knowledge in derivatives you can easily take the derivative of this problems. So for the first one, we have x to the power of 2. This is the function of fx equals to x to the power of 2 plus pi x to the power of 1 over 4 minus e over x over a square root of x. So this was a math problem and midterm problem for Math 41 in fall 2012 at Stanford University. So in order to take the derivative of this function, what we have to do, we can use the quotient rule, or the other thing that we can do, we can just say basically fx is equal to x2 plus pi x 1 over 4 minus e over x, and then we'll bring this to the up and write x to the power of minus 1 over 2, and we can say that this is going to be x to the power of 3 over 2 plus pi x to the power of, so we have 1 over 4, we have minus 1 over 2, so it's going to be minus 1 over 4, and then minus ex to the power of minus 3 over 2. So what we are doing is just multiplying x to the power of 2 with x to the power of minus 1 over 2, pi x over pi x to the power of 1 over 4 times x to the power of minus 1 over 2 minus e over x times x to the power of minus 1 over 2. So this is going to be what we are getting from fx basically. And now we can take the derivative of what we have in here. So d over dx equal to, so for this part we can say, so basically the function is now in here, x to the power of 3 over 2. So what we have to do in here is using the power rule, and the power rule says if you have d over dx, x to the power of n, it's going to be n x n minus 1. So we do the same thing here. So this is going to be 3 over 2 x 3 over 2 minus 1 plus pi times minus 1 over 4 x minus 1 over 4 minus 1 over 4 minus 1, and then we will have minus e minus 3 over 2 x minus 3 over 2 minus 1. So this is going to be the derivative, and we can rewrite it as dfx over dx equals 3 over 2 x to the power of 1 over 2 plus, and basically this is going to be minus pi over 4 x to the power of minus 5 over 4, and then we'll have plus 3e over 2 x to the power of minus 5 over 2. So this is going to be the answer for this problem. Basically what we did, instead of using the quotient rule, we saw that this square root of x can be written as x to the power of minus over 2 basically, and we just brought it up and then we just rearranged the problem based on that and then took the derivative, as you can see, and this is going to be the final answer. So easy problem. The second problem that I'm going to solve is an exam problem from Stanford University, Math 41. And as you can see, the function contains two main terms, x to the power of e times e to the power of x, and the second term is 5 tan x over 1 plus cos x. For the first term, we have to use the product rule, and for the second term we have to use the quotient rule. So in order to take the derivative of the whole function, we have to look at each of these terms one by one. So let's look at the derivative of the whole function, which is dfx over dx, and for the first term, in which we have multiplication of two functions, x to the power of e times e to the power of x, we are going to use the product rule, and the answer is going to be x to the power of e to the power of x plus e times x to the power of e minus 1 e to the power of x. So basically we applied the product rule, which says that derivative of the first function times the second function plus the derivative of the second function times the first function. For the second term, we have to use the quotient rule, and the quotient rule says that take the derivative of the top multiplied with the bottom function as it is minus the derivative of the bottom function times the top function as it is over the bottom in power of 2, and we'll do the same in this function. So it's going to be 5 secant squared x times 1 plus cos x, and now we have to take the derivative of the bottom part, which is going to be minus sine x times the top part as it is 5 tan x over 1 plus cos x squared. As you can see here, we just applied two basic rules and we could solve the problem easily, and the problem was basically an exam problem from Stanford University. Let's look at the third problem. So this is from Math 18.01 from MIT, and it was a midterm problem. Let's look how we can solve it. Basically, we have a top function in here, which is e to the power of x minus e to the power of minus x, and we have a bottom function, as you can see here, and again e to the power of x plus, this time plus e to the power of minus x. And what we have to do for this problem is we have to use the quotient rule. So I'm just writing Q rule, and let's start. So we have d over dx of fx equals to, so for the top part, so the first part is to take the derivative of the top part. The rule says d top times the bottom as it is minus d bottom times top over bottom to the power of 2. So for here we do the same. So for the top part, we need to take the derivative of this function e to the power of x minus e to the power of minus x. So we know that derivative of e to the power of x is basically e to the power of x minus, and the derivative of e to the power of minus x is going to be minus e to the power of minus x. So minus e to the power of minus x, and this is going to be the first term, and this term is going to be multiplied by e to the power of x plus e to the power of minus x. And now let's look at the other term that we have, which is the bottom part, and we need to take the derivative of the bottom now. Minus, and for this case here, we have e to the power of x plus e to the power of minus x. The only difference is the negative sign in between. So we have to do the derivative of e to the power of x is going to be e to the power of x plus, and then what we have is minus e to the power of minus x, and then this is going to be multiplied with the top part, e to the power of x minus e to the power of minus x, and the whole bunch is going to be over e to the power of x plus e to the power of minus x squared. So easy, again, using the quotient rule. And basically in here, what we did is using the chain rule for this, because it is basically e to the power of u, and for here u is minus x, and the derivative of minus x is minus 1. So as you can see, there is no need to simplify it. Basically you can put it as it is. Depends on to the course instructor. If they're asking for simplified version, you have to go further and simplify it as it is, but I'm leaving the derivative as you can see in here, but you can simplify it if you like. So as you saw so far, the derivatives are not that complicated. Using the chain rules, product rules, quotient rules, and power rule will actually enable us to solve several problems, and will be easy. Several actually problems in exams would be easy for us, and we can get the full mark for them if we practice enough. Thanks for watching this video. If you enjoyed watching this video, please subscribe our channel.